Hello class, this is Professor Havens with a quick video on project number 2. The goal of this project is to build an amortization schedule using Microsoft Excel or a similar spreadsheet program. I don't really care which program you use, just make sure to follow the instructions and upload it in a file type that I can actually read. And really the end goal of this project is to have a schedule something like this. Basically, it's a spreadsheet that enumerates all of the data for a loan for its entire life. Basically, how much does it start with? How much are we paying into that loan? What, how much payment goes towards interest, towards the principal, and what happens to this loan over time? Really, well, for one thing, is to have a better understanding of loans and how they work, but also to explore those other amortization formulas from the packet. And you can use all of those as you're working on the project. Obviously, strongly recommended. But basically, there's a few things that I want you to do. Um, is to build the schedule. And for each one of you guys, you're going to have a slightly different problem because the values of your loan and the interest rates are going to depend on each person should have a different amount, or it's randomly generated. But in every case, we're going to assume that we're putting 15% down and that we're taking out a 30-year mortgage. So all that 15% down means is that the price of your home, you have to pay 15% up front. The remainder is what's going to be the principal of our loan, and that's the number we want to use in our amortization formula. Um, so let's say, for example, my name is Kyle Havens, and I want to know, okay, what numbers am I working with? So my first name starts with K, so the price of my home is going to be $600,000. And my last name is H, B, C, D, F, G, H. I don't know the alphabet without singing it. Apparently, my loan is going to be at a 2.75% interest rate. So this is how you figure out what numbers you're going to use. Just use your name to do that. But that's, how I know what to begin with. Or say my name is Amanda Appleton. I'm going to be taking out my home's price is going to be $1 million at an APR of 3.75%. But also, since I'm putting 15% down, my loan is actually not going to be for that full value. It's going to be 15% less. So, to get started with this project, I could go ahead and figure out, well, how much am I putting into the loan? 1 million times 15%. This would be how much I'm putting down. So I'd have to put down 150,000 up front, but that means I'm borrowing the rest in my loan. So that's going to be my principal value, or capital A, as far as the amortization formulas in the book are concerned. But anyways, what I want you to build. Also, I have the general structure of how you should lay out your spreadsheet on the project PDF instruction guide. So what and I'm going to go ahead and try to follow along with that as I build it. But basically, we're going to use the first column for our month by month amount. The balance of the loan will be the next column. You don't have to do it exactly like this, but this is just my recommendation. And as I'm working through a quick tutorial, um, I'll try to follow in the same way and set it up as I have. But you can format your spreadsheet however you want, make it look as nice as you want, like the other one I showed you just a few minutes ago. But it doesn't really matter as long as you're able to build it. That's what I really care about. And then payment towards interest, I'll put here, because as I'm paying off the loan, some of it is going to be to counteract the interest that's accruing, and part of it is going to be going towards the principal. So that's what I'm going to make P arrow P mean. And then basically after each month we had a balance to begin with, and then as we're paying it off, we're going to have whatever's remaining in this column. And basically, as I'm getting started, 1, 2, 3, we could continue for the entire life of the loan as we progress. But basically, what I know is that, like, let's just say I'm using the first example, Amanda Appleton. I'm borrowed $850,000, and also I know my interest rate. That was given by, let's just say 3.75% or whatever. That's going to help me. Obviously, I'm going to need to know that for amortization. Now, if I want to know, well, how much do I need to pay? What's going to be the payment amount? That's what that formula number one was going to give me is what monthly payment would I need to pay it off on time. So let's revisit the amortization formulas in order to do that. So let me pull up the packet real quick, and I'll just use the same lecture notes and formulas that we've been using in the slides and everything else to be consistent. So the payment amount I'm going to need is given by this formula, or A divided by A and P. Now Excel actually does have a lot of functions in it pre-built. I don't want to get into that, so let's just do it with calculator. But in order to find the payment amount, I'm going to start with my principal A, capital A, and that's going to be divided by little a, or essentially it's going to be multiplied by the periodic interest rate. So since I had a 3.75% interest rate, that's what I want to use for everything. Also, since it's compounded monthly, as almost all loans are, that the periodic interest rate would be 0.0375 divided by 12 would give me P. And then to finish up, I need to make sure to divide by all of this, which I'll make sure to put all that in parentheses, divided by parentheses, 1 minus parenthesis 1 plus P, 0.0375 divided by 12. All of that is to the negative n power. And reminder that's the number of periods. So since it was a 30-year loan, and it's compounded monthly, that would be 30 times 12, which is 360 total payments. And I'm going to make sure to close that parentheses because I want to make sure that that whole thing is in the denominator. But I think I've got it all in there. So let's see what my necessary monthly payment is going to look like. So it appears as though I'm going to need to pay close to $4,000 a month in order to pay back that loan on time and keep it up to date. So I'll go ahead and round that to the nearest cent. Also, I mentioned this is that usually round to the nearest cent, but it usually is more sensible to round up, because if I round it down, technically I'm shortchanging my perfect amount that I would need to pay it back on time. And at the very end of the loan will be a little bit short, probably a few dollars, I don't know exactly. But I'm just going to round it up, which is generally what I recommend to do always when using the amortization formula. This is something where I don't care on the test if you round up or down. But basically we got that in there. Also, in terms of formatting, there's a few tricks to make it look a little bit prettier as well. And you can actually have Excel round it for you if you want, but we don't, again, I'm trying to not get too technical into here, but feel free to use anything at your disposal. But you can always center things. You can make a particular row bold like that. Another thing that is typical with financial things is you can actually change the cells to be finance. If you select them all and right click and go to format cells, it actually allows you to format them in various different ways. So you could use accounting, which would be a very common way to do it, or you could use currency. It doesn't really matter. I would generally probably use accounting for such a project, which will then just put the dollar signs in, and it will automatically round them to the nearest cent. And actually, you can have Excel. This is another thing about Excel, is Excel actually can do math for you. So notice how I use my calculator to do this, but an alternative way to do this is if you want Microsoft Excel to calculate things, if you just start your cell with equals, that's how Excel interprets that you want to do math within this cell. So like if I just hit equals, I could have done the same thing, 850,000 times 0.0375 divided by 12. Then I wanted to divide by that whole one, just make sure I'm getting it correctly, 1 plus p, 1 minus 1 plus p to the negative n. And actually, there's a million ways to use Excel more efficiently. But basically, there we have the same thing I type in my calculator. Careful with your parentheses. And I must have messed something up. What was it? Also, if you have typed in a formula and you're getting a different answer than you got with the normal calculator you use, you can always, after you type in something in, this little bar up here, I'll pretend that I made that mistake on purpose to illustrate a point, but you can always see what formula is within a cell. Because once I type it in, all I see is the answer to the calculation, which I did when I'm looking at the data. But if you click on it, you can see exactly the formula up here. And what I could notice is that I missed a zero right there, which I did on purpose, wink wink. But if I fix that, hopefully it should fix my problem, which it did not. So I still have something else wrong. Oh, look, I had a plus sign instead of a minus sign. Another mistake, which I'll pretend I made on purpose. Anyways, you can easily go back and fix your formulas if you're getting a number that's not, if it's just not working or doesn't make sense. But there we have it. But notice it does round it to the nearest cent, not up. So again, I don't care. But cool. Whatever, however you come up with that, it's fine. But when you upload your Excel file or your sheets, whatever, if you upload as a PDF, I can't check. But what I can also do is if you upload an Excel file, I can then check out your formulas and see if something's wrong. I can point out to you guys what was wrong or what went wrong in your own amortization schedule. But also, then the other question is, how do I determine the rest of the information? Because the new balance will be, well, this is how much I started with, and I'm going to be paying this much. But additionally, we can't forget about the interest that's accruing in each month. So what what we can do in this column is designed to be the payment of how much interest is accruing. Basically, we could use this column to calculate how much interest is actually accruing in that month, because this was my starting balance for the month, but I wanted to know how much interest happened. But since we know the interest rate, the periodic interest rate, we know it's, well, 3.75% in this case. But it's also, don't forget to divide by 12, because over 1 month, it's not going to grow by 3.75%. It's going to grow by 1/12 of that. So I can figure out how much interest is accruing, and that's what I'm going to use this column for. So if I take, again, if I use the equal, this is another brilliant thing about Excel. You can use another number in a column to start your formula. So I could type out, say I wanted to figure out the interest on this, I could say 800, like I could type this in my calculator, right? The current balance is 850,000. I could multiply that by the interest rate, 0.0375, divided by 12. And that would give me how much it grew by, $2,600. That's the interest for 1 month. But you can do all that in Excel. That's kind of the point. It's, first of all, it organizes a bunch of data, but it also is its own calculator. And you can use other answers in there. So if I hit equal B2, notice that that's in column B, row 2. All that's telling Excel, and it uses colors to help you see, if you're not colorblind, that is, which cell is being occupied. Or also it highlights them with the little dotted moving lines. But anyways, basically that will take 850,000, and then I can multiply by my interest rate, 0.0375, divided by 12. And this will give me the interest that's accrued in 1 month. And basically, you could also use the formula from the amortization formula. So if you remember, I kind of skipped these formulas in my lecture, and I said don't really sweat these. But this is a totally separate way of calculating exactly what I just found. Sorry, this would be number 3, interest left within the kth payment. And if you want, you can use that instead. But I think that that's a way simpler process, and that's gonna do the same thing that I did, that I did as I just figured it out. Also, another benefit of this is, like, if I know this is how much interest happened, usually the process of amortizing is the process of taking your payment and using some of it for interest and some of it to pay off the principal. Basically, I can use however much I'm paying to pay off the interest, which there's, tax deductions for that part. But also I'm paying off the principal. So if I just take the difference between how much I paid and how much I went to interest, this will be how much is left over, and that's the amount that will actually go off to paying the principal of the loan. And the new balance of the loan is simply going to be the initial balance of that month, taking away how much of that payment went to principal. And this will give me the new balance. And then going forward in the next column, this will be equal to the new balance. And then I repeat this whole process. So I could basically I can imagine my balance is going down as I'm paying it off. But as the balance goes down, the amount which is being paid towards the principal increases and the amount that's being paid towards the interest decreases. And as long as I use the amortization formula correctly, it should be the same payment amount every month. So another cool feature of Excel is that if you look at this cell and notice there's actually a little dot on the bottom right corner, what this dot does is it's like I don't know what it's called, but it's a drag down option, which if you drag it down, it will drag down your pattern. Like notice if I'm dragging this down, it will drag down the same number if I'm just selecting one cell, and it'll just copy it. So instead of having to type that in a million times, it's kind of cool. But another way, this will also calculate mathematical formulas. So in this formula, what it did is it took the cell to the left and it multiplied by this particular interest rate that I wanted. If I drag this one down, notice what it will do is it won't just drag down the number, it will actually drag down the formula. It will drag, and notice like in this cell, it took this value that I selected and multiplied by the amount. Over here, it actually took the new balance and multiplied that amount by that amount. Notice it actually changed because it will drag down the cells that I'm using as well. And notice how it didn't work here because I don't currently have a number in here, but this should work as I continue my formula later. Also, Excel will often be able to interpret patterns. So like in this case, we have month 1, 2, 3, which is kind of obvious what that sequence is. But if you use the drag down option on multiple things, notice how, it's kind of hard to see this on my screen, but notice how it's actually dragging down the numerical values as well. If you just select one though, it's not going to understand that. It's just going to drag down only one. You have to kind of select multiples, and it will try to extrapolate the sequence from that. But anyways, also since what this formula did is it took the difference of those two. If I drag this down, oops, and make sure that you're clicking on this box. If you click like here, it will not do it right. Or if you click right there, it will move the whole cell. So you want to make sure it looks like this as you're dragging it down. But notice what this one does is it will take the difference of those two cells, and if I drag it down, in each case, it's showing me that. But also in the final one, I want to make sure if I complete this table and I just drag all of those down, it should work itself out. I also want to drag down this formula that's using the prerequisite thing. But basically, I'm kind of copying all those formulas, and what it will do is we'll sort of self-generate the table if I'm setting that up correctly. Because we could do all this work manually, but the whole point of using Excel is to try to get around that by using the formulas and using the drag down feature to copy those formulas. But anyways, what you can see is the balance is going down, but also the principal, the payment towards the principal is increasing over time, and the payment towards the interest is decreasing because as the balance goes down, the amount of interest is getting less, so the payment is more and more going towards the principal. And last thing, let me try to wrap this up because this is getting kind of long. But another thing about loans is, in general, you want to pay them off as fast as possible because one key idea is that as it goes down, you're paying off the principal more quickly. So what that's sort of meaning is we're being more efficient in our payments. We're wasting less money on interest. At the beginning, most of your payment is going just towards the interest that's accruing. So you're barely making a dent in your loan at the start, and you're making more and more of an impact as it goes down. But that's kind of a key with loans in general is you want to pay off as fast as possible because you're reducing the balance. The balance is really what we can kind of imagine we're fighting the balance. The balance is generating interest, and as I pay off the balance, it's going to become easier and easier to counteract that payment. And it is technically possible if we don't make enough payments on our loan to never be able to pay it off. Like say, for example, I only put down $2,000 a month on this loan. Since the original interest is this, I'm actually the loan balance is going to go up over time because I'm actually not paying enough. And that's kind of why that amortization formula is key for understanding how much will I need to put into this loan to pay it off. But you can pay more. That's my point. Is like you could put down say 5,000, 6,000 a month. Well, sometimes like very rarely I've heard of loans that have penalties for paying it back early, and in my opinion, that's criminal. But the legality of that, I don't know about California, can depend. I've heard that that's actually possible, but usually there's no negative impact of paying it back early. All that will happen is you're cutting back on interest. So general rule of thumb for loans: pay them off as soon as you can, but just make sure you make at least the minimum payment that has been calculated for you. And if you build your own amortization schedule for your own loans, it will help you understand how they're working. And I could always make an adjustment to this. Say, if, for example, I wanted to pay off $8,000 instead of that. I could it would be a very simple fix if I have the amortization form schedule set up correctly, and I could tweak that and kind of keep track of my own loans myself. But anyways, there's a couple more parts of the project. Um, but another goal is to find when at what point is the principal being paid off more than the interest. If you go down for a while further, at some point, as we can see, the principal payment towards the principal is increasing, where the payment towards the interest is decreasing. At some point, the payment towards the principal will actually go past the payment towards the interest, and that's one thing I wanted you guys to find and use your schedule to do so. But anyways, that will wrap up this little tutorial. If you want any help, or if because that was kind of fast, feel free to drop in by office hours or Zoom meetings or whatever, or just email me questions about anything about the project. But otherwise, have a good day, and hopefully this project is somewhat enjoyable way of using a lot of what we're doing in class.